Hello and welcome. This is the presentation of our paper, What do users expect of bidirectional transformations, that we published in the European Conference on Modeling Foundations and Applications, ECMFA 2020. My name is Rebekka Wohlrab, and my co-authors are Anjorin and Arjya Shankar Mishra. And now I'll briefly present what bidirectional transformations are, and then show you our findings regarding users' expectations. And bidirectional transformations, or BX, are means of maintaining the consistency of two or more related sources of information. And that is pretty useful because nowadays, in systems and software development, multiple teams are involved that create documents and models that should be kept consistent and in sync. And BX frameworks, for instance, the lens framework and its variants, have been developed to check for consistency, restore consistency, and generate consistent pairs of connected models. And all of these BX frameworks have underlying laws that govern the behavior of bidirectional transformations. And so far, it is unclear whether that fits to users' expectations and to the properties that users would consider desirable. In general, we have a lack of understanding of users' intuitions with respect to BX, and that's the gap we try to close with this paper. To really study users' expectations of BX and provide a better understanding of their intuitions. And here our concrete contributions were, on one hand, to propose an experiment design so that users' expectations can be studied more easily in the future. And we also present and discuss empirical data from 2 runs of the experiment. And that can then be adapted to study the expectations of a variety of user groups from different disciplines and backgrounds. And we did the runs of the experiment together with 65 graduate computer science students taking elective courses. And our setup for the experiment was to have a pre-test, then ask them to work with our BX demonstrator that can be found on GitHub, and conduct a post-test afterwards. And this is what the BX demonstrator looks like. It's an example that people can recognize from their everyday lives because it's about kitchen planning. Here on the right side in the kitchen, we can create different items, for instance a sink, but that has to be next to this blue wall with water outlets so that it can be synced. And then we can see that 2 squares in the layout grid have been allocated for this item, one for the sink itself and one for someone standing in front of it. And there's an implicit correspondence link between these 2 squares and this item that we created in the kitchen. It also works the other way around, that we allocate space here in the layout by clicking on it and then can synchronize it. And sometimes there are multiple ways in which a change can be synchronized. And here we ask to provide input whether we want to create a fridge or a vertical table. And now here I decide to create a fridge. And then that is how that change is synchronized. We can also move things around, and that comes with it. And we can create things in places that are not allowed, and then changes can be rejected. You can check out the BX demonstrator on GitHub and see the sync rules and some more information here in the top right corner of the BX demonstrator. And the BX demonstrator actually helped giving a concrete example of BX, but we used an example independent formal notation to ask the questions in our tests that is similar to this one. And we were interested in our subjects' expectations with respect to several properties of BX. One, source totality. So do people expect that there's always at least one corresponding target model for every source model? and also target uniqueness, whether that target model should be unique, whether forward synchronization should depend on the concrete correspondence links and input deltas, and also whether synchronization should be undoable. And for the results, we can start with source totality and this table that gives a summary of the people expecting source totality, and then the second value is always not expecting source totality. We can see the values before interacting with the BX demonstrator in the first column, and then afterwards in the second one. And we have an average of a subjective confidence level between 0 and 1, where people could indicate how sure they were about their responses. The first row shows the values for experiment 1 with 40 participants, the second one for experiment 2, where we have more sanity checks, and there the values do not always add up to 100%. We indicate that an entry is significant, statistically significant, by marking it in bold. And if we look at the results here, we can see that, in fact, source totality is expected by most users, which is weird because the BX demonstrator is not source total. But there we also got some indications by comments that people left and said that they assumed rejected input deltas to be bugs and something wrong with the BX demonstrator. And that is something interesting to keep in mind when interpreting these results. For target uniqueness, on the other hand, we saw that that is not expected by most users, and they are very willing to be involved and provide additional information when there's more than one potential target model. For correspondence links, we see that most participants expect synchronization to depend on correspondence links. That's stronger after the interaction with the demonstrator. For input deltas, on the other hand, there's also a slight tendency that they expect that input deltas do play a role, but there's no statistically significant value. And also for experiment 2 with the sanity checks, we can see that that's a very low number in general. So maybe those questions were a bit confusing. For undoability, we can see that most, in fact, expect synchronization to be undoable, which could be because of the availability of popular platforms like Google Docs, where undoability is a feature that's given by default. And now we can briefly summarize these results and discuss what that might mean. I showed you how we designed and performed an experiment to study users' expectations of bidirectional transformations. And we found that source totality is something that is expected by most users, and they react with surprise when that is not the case. Which is maybe okay for model synchronization, because there we could just magically forbid the changes that cannot be synchronized. But if we look at model integration, there research on conflict resolution is definitely important in this area. For target uniqueness, we saw that non-unique results are acceptable. We just need good approaches for user interaction if they have to decide between the target models that are possible. We also saw that correspondence links are considered important. Input deltas might be more difficult to understand, and there we suggest to work on good ways to view and inspect that information. Finally, undoability is something that is expected, but it is also a severe limitation for BX tools. So we should discuss the consequences and potential alternatives in the community. If you want to get more information on this topic, you can check out our paper. We provide a link in the description of this video, and feel free to contact us with any feedback or questions. Here is the email address. Thank you.